So dear friends, Maths Aspirants is a community of mathematics students, research scholars, and faculty members across India, initiated by myself in 2017. And we used to organize several online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of that series, today we have Rajendra Rajpurohit is with us to discuss some topics from real analysis. Mr. Rajendra is currently pursuing PhD at IIT Roorkee, and he has a rich academic experience, especially in this type of competitive examinations. He qualified NET examination 2 times with All India rank 39 and 36. Also, he qualified CSIR JRF with All India rank 97 and 101. Also, he qualified GATE examination. And he has a rich experience, teaching experience, around 4-year teaching experience in NET JRF coaching. So I'm sure that today we have got a most apt person to discuss problems with you. As all of you know, many competitive examinations are very nearby. TIFR exam is coming in this December. NET examination is also there. And GATE exams and JAM examination are in the February. So I'm sure that today's session will be really helpful to all those who are seriously preparing for these examinations. I would like to express my sincere thanks and gratitude to Mr. Rajendra for accepting our invitation and joining with our community. I welcome everyone to this program. Welcome, Rajendra.
Yeah, hello, sir, and thank you for the introduction. So I just heard about this thing from the professor himself in a text, and then I found it interesting that if we can contribute to this aim for solving people's doubt and interacting with more and more aspirants, it's actually very interesting for me as well. So yeah, I thank you, sir, for the opportunity as well. So first of all, very good evening, all of you, and very welcome to this session. So how this session is going to be, generally that we do in this, as I am aware of, that we do most of the time, we do some practice. So I'll put some questions from recent NET JRF exams. And I have selected 2 topics for today, which of them are countability and point set topology. Okay. Note that these topics are common in GATE, JAM, and TIFR, and all of the competitive exams. But we will be focused on mixed questions from here and there. So if you have any doubt, any query, any questions, you can either raise your hand or unmute yourself and speak up. And also you can put it into the comment section that we can discuss it together as well. And yeah, that is all information prior to the session I think I need to give you. So yeah, good evening all of you. If any of you can confirm that everyone is fine with audio and video part. So we have almost like around 70 people from across the country. I hope all of you are fine with English, because I think we have people from South and West and North. So English will be the common language, I'm afraid. So yeah, shall we start for today? So let us start for today. So here is the first question I have selected for today. It's not so difficult, but not so easy as well. So try to solve it, and then we will discuss the solution within ourselves. I think the question is visible to all of you. It is on your screen. Yeah. So also carry pen and paper. We'll be discussing the concepts behind questions as well. So the question is from your exam, CSIR NET, June 2016, 4.75 marks. And it's about a set and its power set. So the moment you are done, you can answer in the comment section. Otherwise, I'll start in a minute. B and D. Okay, one answer I have is B and D. Anyone else would like to answer otherwise? B and D, B, C, and D. Okay, another differing answer is B, C, and D. Okay, it's a multi-correct question, yes. All right, now let me discuss the solution then, shall we? So we have A as a set, fine. PA be the power set of A, that is usual symbol, and it's given the definition of power set if you don't understand or you understand it otherwise. Then what can you say about power set of A, right? So we do know that the cardinality of A, the number of element in set A, if it is some, whether finite or infinite, whatever it is, if we want to find the power set of A and its cardinality, that will be simply 2 to the power cardinality of A. Okay, there is a rich proof behind it. We really can't go through that proof right now, but there is a proof that every subset corresponds to a characteristic function. Okay, so how the proof works is that if you have some B contained in A, then you have a function f from A to 0 1, which is a characteristic function, right? So for every subset you can have a characteristic function, and such that the number of such subset is equal to the number of such functions, and you have 2 to the power cardinality of a such function from A to 0 1. So thus the cardinality is equal. Okay, but anyways, so the first one is saying that even if your A is empty, then the power set of A will have always at least one element, right, which is empty itself. So the option A is totally incorrect. It is like the most incorrect option here. Now let's talk about other options. That PA is finite for some A, which is obviously true. If I take, you can just take A to be singleton, and that will do for you, right? So PA is finite for some A, that is also true. Now option C and D, C says that PA is countable set for some A, and option D says that PA is uncountable for some A, right? If we take A to be uncountable, then there is no problem at all. If I take the set A itself to be uncountable, then power set of A obviously uncountable. Even though if you take A to be countable, like you take set of natural number, right? If you take A to be set of natural number, then your power set of A that has cardinality, 2 to the power cardinality of n, which is simply you have 2 to the power aleph naught, which is continuum, right? Which is uncountable set. A set which has cardinality at least continuum is uncountable. The smallest uncountable set has cardinality continuum though. So we have that PA is uncountable for some A, that is obviously true. Now there is the problem with this option, this option C, there is a problem. Now what is the problem? That if you have been through books, there is a book for real analysis by Walter Rudin, the principle of introduction to mathematical analysis or something. It's a very small book. If you have been through, it's a very small book, and very compact though, and very good book. The Cantor gives the definition, this Walter Rudin gives the definition of countable set as he doesn't consider finite set as a countable set. He's like, finite is always, it's just finite set. Why would we call it a countable set? It's just a finite set. Countable means for Cantor, for this Walter Rudin, countable means countably infinite for us. Countably infinite. Okay. So in that book from the Walter Rudin, the countable word and countably infinite are same. That means he consider a set to be countable. That means the set has cardinality aleph naught. That's it. So for Cantor, and the Cantor, the actual definition is that if a set is, we say, what do we mean when we say countable? First one is that it is finite, or any of these, or it is countably infinite, or we can just say that it is equivalent to or similar to n. In any of these scenarios, we say that our set is countable, right? But in that book, it's different. So according to that, you cannot select option C, right? Why you can't select option C according to that? Because in this scenario, if you're countably infinite set, that means if you want to look for the cardinality of that, that means that if a set is countable, then cardinality of A will be simply aleph naught, and this will simply imply that your power set of A will have cardinality, continuum. So it can never be countably infinite. In general, what I'm trying to say is that you can make this as a result or as a note point in your notebook, that for any A, it doesn't matter whatever A you choose, for any set A, power set of A is never countably infinite. It's never countably infinite. And why so? Because we have two scenarios. First, A is finite. And second, that A is infinite. Right? These are the only case we can consider for any set. Either it is finite or it is infinite. In this case, PA is finite. And in this case, what actually happens is, if your set itself is infinite, then the cardinality of the set is at least aleph naught. If cardinality of a set is less than aleph naught, then it is finite. And this implies that the cardinality of PA, the power set of A, will be greater equal to 2 to the power aleph naught, which is greater equal to continuum. And hence, in this case, PA is uncountable. That means either PA is finite set or PA is uncountable set. So this statement, for any set, PA can never be countably infinite. And that is what used behind the explanation. In the first time when they gave the answer, when the CSIR made the answer key, they gave the answer to be B and D only. Okay, but then people gave the references of other books which consider that finite set is also a countable set, isn't it? So then C is also true, that if you just write count in place of countable and you just take A to be finite, then it is finite. PA is also finite. That works. So in that case, your correct answer would be B, C, and D. So the actual correct answer is B, C, and D. But again, you can argue with the book, that you can give the reference of that book and you can say that I have been through this book, and obviously the Walter Rudin is very reputed book. So you will get mark for B and D, and B, C, and D both. Okay. So yeah, I hope you understood this. If any of you have any question or query about this, you can ask. Anyone? So a good student always, yeah, good. Okay, so a good student always makes note of something which he learns new every day, right? So if this theorem is new for you for the first time, you will make it a small note in your notebook and keep it in your book of results. Okay, so that's a sign of a learning person. So try to be one. Okay, now the next one I'll be talking about a very recent question in ℸ𝒈 exam. I think it's from last to last exam. So let's talk about that. This next question which I'm talking about is actually mixed up with sequences. So again, interesting one. So I think, let me just paste it here. Okay, this pen is not going away. Just give me a second. Fine, stay here. Okay. So this is also from very recent exam of ℸ𝒈 itself, where you have given two sets X and Y, and then they talk about their countability and all. Okay. So I think question is clear to you, all of you. Is it visible? I mean, I hope no one is facing problem in that. Okay.
Visible.
Yeah. Okay. So try to solve this. Before that, I can point out two things here, that today we are discussing a question from the countability and point set topology. I can talk about their marking quota, that you might find a little bit interesting for you. So if we take it as a subject, then these two are considered in as a part of the subject real analysis. Okay. So in real analysis itself is a very big subject, considering for the whole syllabus for ℸ𝒈. So yeah, in real analysis, we have these two chapters which we are discussing today. One is countability, and other one is point set topology in R. I'll take question from here as well. Okay, so if we look in the exam from this particular these two segments, then you find one question in your every exam from here. I mean, mostly in gate 2 and in net it is surety, almost like 99% chance is there that there will be one question from this particular topic, countability. Okay, sometimes they connect it to the different topics, like the question I gave you above. This one is connected to sequences and limit of a sequence. They have even connected it to point set topology as well. In that case, you can count that question in both of them, like how many dense subset you can find in R. That was previous to previous year question in net JRF. Like you can find countable, you can find uncountable, and something like that. So there is absolutely one question fixed from this particular topic. In very rare scenario you can expect two, but one is for sure. The other one is point set topology. It's actually the topology in R only. We don't consider go to usual metric spaces and then define definition in metric spaces, open ball and all. No, we just fix it to R. And for us, the metric is standard metric. Distance between x and y is mod x minus y. And we consider every scenario in this particular topology. That means open intervals, open set, close interval, close sets, limit points, and all the results, dense subsets in R, and all of that. From here alone, you can expect two questions. Okay, but the interesting thing about this is that many times they ask you question from the general topology, like from general metric space they have asked you a question, or from general topology they have asked you a question. But by just using this topology in R, you can discard 3 options in part B and select one, and in part C sometimes you can discard 1 or 2 options, which is actually helpful. At least it is helpful that you can discard 2. It is really helpful. So in that case, you can solve up to 2 questions from the topology as well. So that is actually a good part from this segment. Anyway, so that is marking quota for these topics which we are discussing today. Around, you can say that 3 questions you can expect in your exam, at least. There may be more. Now, if we talk about this, the concept behind this is, so this chapter countability, you can consider it as a small chapter. That's how you study a big subject. You break it into small parts, and then you study one part, work on one part, and then you move to the next part. Now, what do you need to be careful about is that you consider your each part to be in a way that 2 part doesn't cross their path. Like if you are going through countability, you must not get into sequences or get further. You need to set them in a manner that it comes one after another. Like you are going through limit, then you go through continuity, then you go through uniform continuity, then you go through differentiability, right? And then you go through uniform convergence. So there is a pattern of how you can complete syllabus of a particular subject. So you need to follow that as well when you are covering the theory part. Anyways, let us get back to the study part. If any of you have any general question, you can also ask, because I want this session to be interactive. Okay. So here it's your question. Your question is on your screen. So you try to solve this, and then I'll discuss the solution of this particular question with all of you. Try this out. The question mixes 2 topics, sequences and countability. Okay, so if I can make it a little bigger, yeah, better. D. Okay, one answer I have is D. Anyone else wants to try otherwise?
Option C, X is uncountable and Y is countable. Option C.
Option C. Okay, another answer is C. You can answer in the comment section. Okay, that will also work. I can just read the comment. Okay, so people agrees. Some people agrees with C, and some people agrees with D. Okay, so let me solve it now. So you have given two sets, and both of them contains sequences in 0, 1. Okay, so let me talk about each of them one by one. Okay, right. This pen is really irritating us. Just give me a second. I take it to another book. Okay. So in set number 1, we have all those sequences whose limit supremum is 1, and all those sequences whose limit does not exist. Okay. So now our sequence actually belongs to 0, 1. So xn is in 0, 1. Now let us consider a set, another set, call it A. So I take a set A in which I consider all the function, all the sequences, all the sequences xn, such that xn is a sequence in 0, 1. Okay. Now can anyone tell me that whether this A is countable or not? This set which I have defined, whether it is countable or not? Yes? It's
Uncountable.
Yes. No, the 0, 1 actually defines just two elements, 0 and 1. Okay, it's not a interval. It's set with two elements. Okay, this set is uncountable. And why is that so? Because you can actually prove that a sequence is nothing. Not actually prove, it's a definition of a sequence, that a sequence is nothing, but it is a function whose domain is set of natural number, and codomain is whatever in the terms of your the values that taken by your terms of the sequences. Like in this one we have 0 and 1. So how many sequences you can have? Exactly as many as functions you can have from n to 0, 1. And this, the set of all function from this set to this set, the cardinality of simply this set is that you take 0, 1 cardinality of this set and whole power cardinality of domain. I think you all know that result, that if you take a set of all function from A to B, then collection of all such functions will have cardinality of codomain to the whole power cardinality of domain. Okay, if you take from A to B, then cardinality of B to the power cardinality of A, right? And thus you get 2 to the power aleph naught, which is continuous. Right. So this set actually, if you take all the sequences, that is uncountable. Now they are putting restrictions over this set only. Right. Now what restrictions they are putting is the very first set X, they are putting restriction is that whatever sequence you have, it should have a limit supremum as 1. Right. So that means you take all those sequences xn such that you have limit supremum of xn to be 1. Okay. So your sequence can have 2 limit point at most, because the sequence is in 0 and 1. So either it can have only 1 as a limit point, or it can have 0 and 1 both as a limit point. Done, that is fine. Now you want to have all those sequences in which limit supremum is 1. Okay, that means 1 should be a limit point. That's it. 1 should be a limit point. That means you only want to take all those sequences xn such that 1 is a limit point of xn. That's it. You are not putting restriction over the sequence that after some term it should be 0 or after some term it should be 1. No, that you are only taking all those sequences xn such that xn equal to 1 for infinite n. If a sequence attains one value infinitely times, then that becomes a limit point of the sequence, right? Okay, now we can look at as another point of view. If I take x complement, that means xn such that xn equal to 1 for finite n. And xn belongs to 0 and 1. Okay, if you look at this complement, it is just set of all sequences which are eventually 0. right? Because your sequence can take either 0 or 1, and you can take 1 only finitely many times, right? So that means the rest of the term is 0. This is a set of all sequences which are in 0, 1 and eventually 0. After some terms it becomes 0. Is countable? Obviously, that I think you know, right? So the complement is countable, and you take x union x complement, then you get this set A, this set A, all the sequences, obviously this. Now we know that this is countable. We also know that this is uncountable. Now what can you say about this set X? Anyone?
X is uncountable.
X must be uncountable because it is a complement of a countable set in an uncountable set. Thus X must be uncountable, right? And we can easily select that your X is actually uncountable. Option A is gone because it says X and Y are uncountable. X is countable, that is also gone. X is uncountable, X is uncountable. So we are left with two options now. And now let's look at Y. Okay, Y says that all those sequences whose limit does not exist at all, like limit doesn't exist. Okay, now look at it very carefully, that if you take all those sequences whose limit supremum is 1, okay, and you are taking all those sequences whose limit does not exist at all. So, so, I mean, can you say which is subset of which one? Like, is there any relation between X and Y? Can you find any relation between X and Y? So what actually we are doing is that either the sequence can have limit supremum 1. If a sequence has limit supremum 1, then there are two cases. One is that the sequence is convergent. In that case, it will converge to 1 only because 1 is one of the limit point. And the other scenario is that the sequence is not convergent. In that case, limit doesn't exist. Limit, okay, limit point is there, but limit doesn't exist. That means your Y is actually proper subset of X. Proper. Okay. Now you can actually take all those sequences in this case. In Y, what you can take is you can, Y can be written like this. You have Y to be all those sequences X n belongs to 0, 1, such that X n equal to 0 for infinite n, and X n equal to 1 for infinite n. That is the only possibility for the sequence to not have limit, right? Now what can you say? You can think of it as a layman language, that you want to make a sequence in 0 1 0 1 1 0 0 1. You can have random sequence, but for each places up till it doesn't matter that at how many steps you have reached, yet you don't know whether it will be 0 or 1, the term. Okay, that's what actually not countable set is, that you cannot tell what will be the pattern of the elements. What is countability? You say a set is countable if you can actually recognize, you can put them into a process, that this element, after this element, after that this element, right? So that you know that what is the successor and what is the predecessor of every element. If you can put a set into such process, then you say the set is countable, whether it is finite or infinite. But here you can't. You cannot actually recognize that at whatever process you put, what will be the some random entry of a random sequence. You cannot put it into the process because 1 is infinite time and 0 is also infinite time. So the terms are random. Sequence is not fixing itself, right? Whereas if I fix this same sequence, that X n equal to 0 for finite n, now if I take any sequence from this, if it is 0 for only finite n, that means for any X n belongs to Y, there exists some K such that X n equal to 0. xn equal to 1 for all n greater equal to k, because after some terms it will become constant 1, because 0 is for finite only, not infinite. Okay, so that is how the the word countability is there. You just need to make it senseful. Again, you can write it as a complement of the countable set and proceed with such method as well. Okay. You name, you can write A as y union y complement, and your y complement is actually, you will have either x is 0 for finite n, or y is 0 for finite n. In that case, that set will be countable. Okay, so y complement is countable. You can easily prove that. So the correct answer will be that your y must be, y is also uncountable. Both of them are uncountable. So y is also uncountable. This is also gone, and correct answer is D. I hope you understood the concept behind the question. Anyone, any question about this?
No, sir.
Okay, all right. Let us move to the next question. I'll take a little bit easier type of question. So this question is from NetJRF only, a little bit old. Try this out. Okay. So you have given some subsets of R2, and then you need to talk about their countability. Okay, so think about it and try to answer in the comment section. ABD and ABC mixed answer I'm getting. Okay. Okay, so let us discuss it together. So how do you show a set is uncountable? In generally the method is simple, that you somehow show that in the given set there is an uncountable subset. That will suffices. That if you can show that there is an uncountable subset of the given set, then your set must be uncountable. So that is what we are going to do. We are going to show that each of whenever whenever there is a we will show that any set which is uncountable here, there is an uncountable subset contained in it. So let's try to fix that. First of all, if I look at option D, if I am in the exam, and I can easily verify that it is actually Q cross Q, right? And we also know that Q is countable, and hence finite Cartesian product of a countable set is countable. Why only 2? If they have given us some more, like 2002, still it would be countable, because A and B are rational, so Q cross Q only, that set must be countable. So option D is countable for sure. So we will eliminate this one from our list. Let's look at A, B, and C. Now, if I look at A, I want to show that it is uncountable, then I need to show that there is an uncountable subset. So let's call it A1. Now I'll make an uncountable subset in this one. So I need A and B such that A is less equal to B. What I can do is I can fix one of them. Let me fix one of them. Let's fix A. Let's fix A to be 1. So what I have is, if I fix A to be 1, then I get 1 comma B. Okay, now your B must be greater or equal to 1. That means B belongs to, B should be greater or equal to A, and it should be from R, right? So B belongs to 1 to infinite. But this is my set, right? Now let us call it S1 or something. Okay, let's call it S1. Right? You can easily see that this S1 is actually subset of A1. Obviously, because this satisfies the condition. Now you can show that you take any element from here, like 1 comma B type of element, and map it to B. This is a function from your set S1 to the set interval 1 comma infinite. You can easily show that this map is actually 1 1 onto hence bijection. Thus cardinality of S1 is same as cardinality of 1 to the power infinite, sorry, 1 to infinite, and it's continuum and the set is uncountable. Right? Same we need to do for the second and third. We have showed that there is an uncountable subset in option, in this set even, which is this one. You can fix B and you can find. That's totally subjective. Let's look for the second one. Now in the second one, what they are saying is that A plus B must be rational. Okay. So how do we do that? What I do is I know that if you have two real numbers, even though they are not rational, their sum can be rational. It's possible. So I'll use that fact and I'll choose these kind of irrational number. Like you see, if I take 1 minus pi and I add pi into it, I'll get simply 1. Right? That's rational. That means this element 1 minus pi and pi, if I write it as a coordinate 1 minus pi and pi, that is actually an element in my set. Let's call it A2. And I will use this fact. Okay, so what we do is, let us fix these kind of number 1 minus alpha and alpha. Alpha belongs to Q complement. Now if you add A and B, then you get simply 1, which is rational, and hence this, whatever this set, call it S2. This is contained in our set A2. Now can you say S2 is countable or uncountable? How many elements are there in S2? Anyone? As many as irrational you have. Alpha is from irrational, no?
Uncountable.
Uncountable, and thus B is also uncountable. Right? Similarly, in C, you take 1 by A and A. Right? A is non-zero. Then their product will be simply 1. A belongs to R minus 0. So you can show that this set, which is uncountable, similar to R minus 0, is a subset of this set, and hence C is also uncountable. Okay, so correct answers are A, B, and C. Let me take the next question. You can ask if there is any query or question you are having. This question is kind of a little bit popular. I hope you have faced this problem in your life once. Let us talk about each and every option in this question. Try to solve this. This is from June 2019, 3 marks. Okay. B, everyone agrees with B. Okay. Now, if you look at the question, it is very easy to find the answer in exam and solve in the exam, because it's, if you look at all 4 options and not solve all of them and solve the easiest one which you can solve, then it is very easy. The concept is same as we discussed in the last question, that we look for an uncountable subset, right? And you can easily, a blind person from the mathematical background can see it, that if you take all those, if you just fix n to be 1, just 1. So if I take n equal to 1, not 1, 2, we'll have to fix 2, then you can just do this, that cos x whole square plus sin x whole square. This thing is 1 for all x belongs to R. That means if I take n equal to 1, then I'm not sure, but if I take n equal to 2, then this set is actually set of all real number, because for every x belongs to R, this equation satisfies. So the set is whole real number and hence uncountable, and I'm done with my problem in the exam, and I secured 3 marks. Now, because we are not in the exam, we have to solve A, C, and D too. What will be, how can we solve that? A, C, and D. So let us look for one by one for all these options. Anyone would like to give any hint for option A? Like why option A is not true? Why option A is countable? What is the reason?
Log x is 1 function.
Exactly, yes, good, Satyam. So the very reason is that the log x is actually 1 function. So since log x is 1 function, we can say that what I want in the range, I am taking a function f. What I'm actually doing is I'm taking a function f from r positive to r, let's say, okay, and I want f of x is equal to log x, right? And what I want is I just want the inverse image of q positive from here, right? Because I want that all those x for which log x equal to, log x belongs to q positive. It means inverse image of q positive, because p by q for all pq belongs to n is actually q positive, set of all positive rational numbers. And since the map is 1 so the inverse image of q positive under this function will also be similar to q positive. So whatever inverse image is, that means f inverse q, whatever it is, it will be similar to q itself. Q positive is similar to q positive because of the map being 1. So there is, for every element in the codomain, there is exactly one inverse image, and hence they will be similar. Under a 1 map, you can easily imply some things, like if you have a 1 map from any domain to codomain. So what can you imply when you have a 1 map? Let's talk about that. Let's say that you have f from a to b, 1 map. Then the very first and immediate result is that for every element in a, you have exactly one element in b, exactly one. This implies that a and fa have the same cardinality. Second is that you can easily claim that that f inverse a has the same cardinality as of a, because the map is 1. So these results you can apply. And the final list is that you see that cardinality of a is same as fa, and where you can easily see that fa is actually contained in b. That means the cardinality of b will be at least cardinality of fa. That means cardinality of a is less equal to cardinality of b. These results about 1 map. If you have a 1 map from one set to another set, you can easily imply these results. How about having an onto map? What if there exists an onto map? There exists f from a to b, which is onto. And what can you say about this one? So in this scenario, the very first result you can make is that for every element in b, you have at least one element in a. That is definition of onto, no? That every element from here has an inverse image. Now, one inverse image, more than one inverse image, that we don't know. For every element in b, we have an inverse image in a, right? So we can easily make very first result is that the cardinality of a is always greater equal to cardinality of b. That is all. That is all countability is about. This result, this third one, and this one. That's it. If you have a 1 map, then this. If you have an onto map, then this. Done. The whole chapter is done partially. Okay. So cardinality of a is a greater equal to cardinality of b, that you can apply when you have an onto map. Yeah, right. And all these results you can't have here. Anyways, let's get back to our question. These results you can make make a note. Now let me look at this question again. So since the logarithmic function is 1, I can easily put that the number of all such x such that you get p by q is same as that of how many p by q you have, and how many p by q you have for pq belongs to natural, as many as positive rational numbers you have. That means this set has cardinality exactly as many as there are positive rationals, and hence it is a countable set. Similarly, how about option C? It's just inverse. You apply inverse e to the power x equal to p upon q. Now exponent function is also 1. So how many x you can have? As many as p upon q you can have. And how many p upon q you can have? as many as positive rationals you have, this is also countable. Now the problem is in option D. How do we show that D is also countable? Anyone? Why D is countable? Satyam have a problem that x square plus y square equal to 1 upon n square. Xy belongs to Q. Okay, we will take that problem through. Yeah, I think I can find that problem. It's also some P by Q. Let me try to figure it out if it is there, if I have it. In the meantime, if any of you can answer my query, that what about option 4? How do we show it is uncountable? I mean, sorry, countable. Anyone? Anyone? Why it is countable? Nobody knows. Let's look at it in this one. So we will use the same concept that the map is 1 1, but cos x is not 1 1. Cos x is not 1 1, but it is in some subset of R, and we will use that. Okay, what do I need? I need cos x to be, okay, you go away. I need cos x to be P upon Q, right? And I want all those real numbers. What I do is I will fix them. I will fix x. I don't want for all x from R. I will fix x in a manner such that my cos x is 1 1. You all know the graph of cos x somewhat looks like this. This. Okay. So we will restrict it in one particular domain. So let us fix from here only. I'll take this block 0 to pi at 0 1 at pi minus 1. Now it is repeating values, right? Whatever value here, it is same, giving you same value. So it is repeating, not 1 1 anymore, right? So I can restrict the function into this whole domain. In this one, your cos x is 1 1 function. Yes, at the same time, cos x is periodic as well. So as many as point you get here, exactly number of point you will get in the second block as well, and exactly number of point in the third block. So how many point you get here will be the exactly number where cos x equal to P by Q you will get here, and you will get into the next block, right? And in this one, your function is 1 1, right? So cos x equal to P by Q will have at most countably many solution, because the function is 1 1. For any x you are getting P by Q, there will be only, P by Q can be attained once only because of the being function 1 1. Okay, so here you have countable, here you have also countable, and here you have also countable. So you have broken all real line into small parts, and in each part you have countably many elements. So your set can be written as countable union of countable sets, and hence the set is what? Countable. Okay, so what we did is we restricted the function in a manner such that in a particular domain it is 1 1, and then we are taking union of, because of the periodicity of the cos x function. Okay? And hence this is actually a countable set. So the actual correct answer is C only, but we are interested in knowing what are the reasons behind other options. Now I'm having a question in the doubt section. Let us discuss about that as well. So the question is that is taking a set S and collecting all those real number x and y. Let me check the question again. If any of you have any query, you can also, yes, exactly. You can also put in the comment section. X, y, such that x square plus y square is 1. X square plus y square equal to 1 upon n square. right? And you have that x and y both belongs to Q and n belongs to n. X, y belongs to Q and n belongs to n. Okay. Now, can anyone tell me that whether this set is countable or not? Anyone want to answer this? You have a collection of all those ordered pair in R2. This is subset of R2, such that their square is equal to 1 by n square for some n, whatever n you choose. There is some n. I mean, I think it is for all n keys. It's countable. How can we say that? You know, in mathematics, we are always interested in knowing the reason. What is the reason? Why? You know, as many times as you can ask yourself the question why when you are not in the exam, it will be, you know, very helpful for you. When you go to the exam, you don't need to ask, right? But when you are doing problems at home, you need to think of every possible, you know, explanation, every possible question you can get over a question. You know, edit the question, think what if this, what if that, then what will happen. That will help you in the exam, because the questions are always in the neighborhood of the question in, you know, which have been asked in the past. Anyways, so how do I prove it? How do I prove that this set is countable, or if it is not countable, then how do I discard it? Okay, so now very first thing is I can see that in this one he has taken that x is and y both are rational, right? X and y both are rational. I think there is something wrong with the question. Is the question is fine? Because in that way it is very easy to see that it is a anyone would also is the question is fine, or is there any issue with the question? I think there is an issue with the question. If not, then we will edit the question to make it interesting. Anyone?
Sorry, X belongs to Q or Y belongs to Q.
Yeah, either one of them belongs to Q. That is guarantee. We don't know about the other, right? That will make the question interesting. Yes. So we have that either X belongs to Q or Y belongs to Q. So we have that. This is not the condition. It is X belongs to Q or Y belongs to Q, because otherwise it is just simply a subset of Q cross Q. If you take all Q cross Q, then it is fine. Now it makes it interesting. Now we need to see that whether it remains countable or not. How do we do that? So now what we do is we assume both cases. Let X belongs to Q. Okay, so let X belongs to Q. Let X belongs to Q. Now, do you see the symmetry that X square plus Y square is 1 by n square? It doesn't matter if I interchange X and Y, it's same. So there is a symmetry. So this is actually without losing the generalization, WLOG, without losing the generalization. I can take Y belongs to Q as well, and then the same process will follow. So let X belongs to Q. This implies X square plus Y square is equal to 1 upon n square. Now X is in Q. This implies that X must be some P square upon Q square. You know, P upon Q, P square, P upon Q. This implies I have that Y square equal to 1 upon n square minus P upon Q whole square. What, can you say anything about the Y? Can you say anything about the Y? You have taken X from the Q and you have gotten Y, you are getting Y to be like this, the square root of this. It's simply that at most 2 solution, because it is a square equation, at most 2 solution. At most 2 you can get, right? So, and same for the Y. So if you fix any X belongs to Q, then you have at most 2 choice for Y, Y1 and Y2. And how many X you can have? As many as rationals you can have. And how many Y you can have? At most 2 cross Q. Now can you say anything about the countability? Because fixing the X is also putting the restriction over y as well. If you fix x to be rational, then y doesn't become rational, but y square become rational. That means y is an algebraic number. That fixes that even the algebraic number is also countable. So you
Y
can,
may be irrational.
yes,
Y may be irrational.
y may be irrational, but it cannot be transcendental. It will be algebraic because the square is rational. Getting me? Any irrational number whose square is rational is actually algebraic number. So this S is actually contained in Q cross A, set of all algebraic number and set of all rational numbers. Or you can write it vice versa, A cross Q. You know, it can be both of them at most. That's it. Because you can choose the opposite too, right? So at most A cross A, I don't think it can exceed that. You cannot have any transcendental number here. All algebraic. X and Y both must be algebraic. And why so? Because they are solution of equation with rational coefficients. That is definition of algebraic number, no? So they are all algebraic number, and hence the set must be countable. I hope it is clear. It's not rationals, but the square must be rational. So I mean, if you can have this kind of question as well, you take let's say that S, all those X belongs to R, such that X to the power n belongs to Q for some X, for some n belongs to n. Then what can you say about this set? New question, garam taja question, fresh. What can you say about this one? All those real number whose sum power is rational. Anyone? Countable? These are algebraics, na? If you take Px equal to x to the power n minus p upon q, right? Then if you take this kind of polynomial, then your element become root of this. Your element, this x, become root of this equation. This is the equation with rational coefficient and hence an algebraic number. So this S is contained in set of all algebraic number. And R can be broken into two parts, set of all algebraic number and set of all transcendental number. This is uncountable and this is countable. And here, if you take any X and its any power, it's never algebraic. It's never rational. It's never integer. Like pi, exponent, pi to the power e to the power pi, 4 pi, 6 pi, jo bhi. They are never algebraic. Okay, they will remain transcendental. Sum of two transcendental number need no transcendental. Sum of two algebraic number is always algebraic, and hence set of all algebraic number, ये वाला field बन जाता है, field. This is a field, subfield of R. This is not even closed with addition because 1 minus pi plus pi doesn't belong to 2. So this one doesn't form a field. It's not even a group. This is a field. Okay, so that we can talk in algebra. Anyways, so I mean, you can partition R into two parts. One is this, that R can be written as algebraic and transcendental, and the other one is that R can be written as rationals and irrational. Right? And what is the relation between these two partitions? Also, at the same time, you can make sure that their intersection is trivial, right? That is also there. A intersection T is empty, and Q intersection Q complement is also empty. That is why I'm saying the word partition of a set. You can look at them using Venn diagram, that how they are related with each other. This is how they are related. So you have this is set of all real number, let's say, and you have a set of all rational. Let's say this is set of all rational. Okay, and this is your set of all irrational inside it. This is irrational. There is nothing common in them, right? Q and Q intersection has nothing in common. Sorry, Q complement, right? Now I'll give you the transcendentals inside it. These are your transcendental. So all the rational number are algebraic. Some irrational number are also algebraic. So these are transcendental. Okay, and these are algebraic. So every rational is algebraic. Every irrational is transcendental, no. Every transcendental is irrational, yes. There is nothing common in algebraic and irrational, no. There is common. There is, this part is common. No? Those elements whose sum power is rational are actually algebraic number. Like square root 2. Square is 2, rational, it's an algebraic. This irrational number is algebraic. Okay, so that's like. Anyways, that's some general knowledge. Countability of Q intersection square root 2, square root 3. Why do you have problem in that? You know, if you have a countable set, it's every subset is countable. You can ask your question. We are taking general queries now. So the question is that you take any A is countable. If A is countable, and B is contained in A, then define F from B to A, F of X equal to X. Identity map, it is 1-1 map, may not be onto. This implies F is 1-1. This implies cardinality of B is less equal to that of cardinality of A. We had the result just before a moment. This implies if A is countable, B must be countable. And what is the corollary we are having? The corollary is that subset of a countable set, that cardinality of a subset can never exceed that of set, right? That we can write. For any B contained in A, cardinality of B is less equal to cardinality of A. That is what this result says. That if you take B contained in A, then you can find a 1-1 map, and hence you can apply the cardinality result. This is about infinite. We need theoretical proof. We cannot just say in air, right? So we have a proof for that. And now you are taking that your set is about minus square root 2 to square root 2, and you are taking intersection with Q. Isn't this contained in Q? Right. You can take anything, like for any A contained in R, A intersection Q is countable. Obviously. No, for any A contained in R, A intersection Q is countable. It is always. All right. Anyone else would like to ask something? Otherwise, I'll put another question. Okay. If they ask in R, wherever they ask, because now it is a subset of Q. If you take intersection with Q, then it is going to be always countable. whatever set you take in this world, if the intersection is with Q, it is countable because it is a subset of Q now. Whatever the things come, it is a subset of Q and must be countable. Okay, try this out. By the way, I have an update for you. If any of you don't know so far, you can get more practice questions with the answers on the website which I am developing nowadays. You can just simply Google. On the Google, you can write the name R² mathematics. I think some of you may know and some of you may not know. You can simply search R² mathematics on Google. You will find a website on the top. In that you can find many practice questions with solution for NET JRF and some books, and I'm trying to develop it very good, so you can get some help from that. I am sure that it will be helpful for all the people who are preparing for NET JRF. So you can just simply go there and check it out. So anyone would like to solve this one? Any answer? Yeah, you're welcome, Satyam. The question is from point set topology in R. So let S be an infinite subset of R such that S intersection Q is empty. All true. One answer I'm having is that all options are true. Anyone else like to answer? Okay, good enough. All B. One answer I'm having is B. All and B. Anyone else? D is also there. Okay, D. A and C are left. Anyone would like to put A or C? Okay, at least A and C are not there. Okay, let's try this now. What do we have here? We have that S is an infinite subset of R. Infinite subset of R. Such that S intersection Q is empty. Fine. All right, that means this S is actually contained in Q complement. Now what? S must have a limit point. Why should it have a limit point at all? Every subset of a rational number has a limit point. No. Every infinite subset of rational has a limit point. If it is bounded, it must. Every bounded subset in R which is infinite has a limit point. So we will take an infinite subset of R which is subset of irrational as well, but not bounded. Let's take this for option A. Let's take this S equal to square root P. P is prime. This is contained in Q complement because every square root P, P square root of P is never, a rational. It's always an irrational number. Prime is never a perfect square. It's not even a square. So these all are irrationals. This is an infinite set. And intersection with Q is empty. How many limit points are there? No limit point at all. Why no limit point? Because numbers are like this. Square root 2 is here, square root 3 is here, square root 5 is here. See the gap between them. How can you get a limit point if there is this much gap between numbers? So S must have a limit point. No, we will not going to read further. S must have a limit point. No. Okay. S cannot be closed in R. R set is closed because it has no limit point. and S derived, which is empty, contained in S. That is definition of closed set. A subset of R is closed if and only if it contains all its limit point. And now there is no limit point. So the set must be closed. R set is closed. A, B, C all gone. Only D left. How about D now? R minus S must have a limit point which belongs to S. That we have to see. Okay. So let's talk about this now. So we have that. What do we have? We have that S intersection with Q is actually empty. Right? This implies Q is contained in R minus S. Right? Because if you take S from set of all real number, you are not taking any rational number at all. So Q is contained. This implies Q derived is contained in R minus S derived. Now what is Q derived? Set of limit point of all rational number. What I can imply from here? That every real number is a limit point of R minus S. If a set contains no rational number, then its complement is dense in R, because that complement will contain rationals. So R minus S is dense in R. Must have a limit point which belongs to S, yes, which belongs to Q, yes, which belongs to Q complement, yes, because it's all R. So correct answer is option D. Anyone, any issue with that? All gone. A, B, C, D, all gone. Only D left. Why so? Because it is dense. You are taking a subset of all those numbers which none of them is rational, and if you take it out from the real, then your rational is there, and that alone is dense in R. Okay. All right. I hope it is clear for everyone. Anyone has any issue with that? Okay. Let me get to some more problem from the topic points at topology only. One or two, then we'll stop. You can, any of you can ask your questions if you have any. Any of you, I'm open to your problems. Like even if you have a general query. I mean, when I say general, I mean the problem related to NET JRF exam and mathematics exam. Okay, don't start with your personal problems. Try this out. Last question for today. It's easy. I think every one of you can try this. Any answer, anyone? C, the complement of NET. Yes. Okay. So, I mean, in the competitive exams, you have two ways to solve a problem. One is to solve the problem and other one is to discard other option and not solve the problem and get the answer. So in exam, it's allowed, both of them. So to get the answer, you can apply other one as well, right? So like if you look at this one is saying that the interval 0, 1, right? The interval 0, 1. So you can easily say that the 1 and 0 doesn't satisfy this equation. 1 square is not greater than 1. So 1 cannot be in this set. This is gone. Right? The complement of the interval 0, 1, the complement of the interval 0, 1 also contains 1. And 1 is not in our set. This is also gone. This is trivial. Saying empty, no x satisfy this equation. Then problem is solved. By just using x equal to 1 is not in our set, I can solve the problem. It's 30-second problem. Now we can solve. Now we can solve easily that we can get assurance about C. I have that x square must be greater than x. Right. So I have x times x minus 1 should be greater than 0. Now we can use that line rule like this. So you have two zeros, one at 0 and other one is at 1, and then you make the graph of it, right? So you want this to be positive, so it is positive here, then become negative, then it become positive. So this, I think, wavy curve method to find sign of a function of a polynomial, right? So here it is positive, here it is positive, here it is negative. So this part and this part is your answer. That means complement of closed interval 0, 1. Rest of that it is positive. So correct answer is C. Yeah, from graph also you can have. All right. So I think we should stop here for today. Enough time, I think, for the session. If any of you have the question, there is one question from from the topology. Let n with the usual metric d, which of the following is true? Usual metric you are taking only. Any finite subset of n is open ball. Open in n, yes. Open in n, yes. The set 1 to n is an open ball in nd for all n. The set nn plus 1 is an open ball in nd for all n. Any infinite subset is in any subset. If you take the usual restriction over n, you need to look at it. If you have, you are taking x to be r, okay, and now you are taking your set, let's call it y to be n, and now you are defining subspace topology on y. Actually, that's what you are doing, right? This is of discrete point. If you take a subset of R which is like this, which has no limit points, then it actually defines somewhat discrete. Okay, you take any subset, like you have taken any A contained in N, then your A must be like, let's say it is finite, so it is A1, A2, so on, AN, like this only. So let's say that you take A1 minus 1, let's say it is in increasing order, A1 minus 1 and AN minus 1, intersection N. This is your A. You can take 1 by 2. This is your set A or not? Because you are taking all the, all the numbers, assuming that A1 is less than A2 is so on, less than AN. Any finite set can be written like this. Now, if you take any A and A can be written as some U intersection Y, then A is open in Y if and only if U is explanation. I hope the person who asked got it. Yeah. Who asked this? Is it clear? Yes. All right. Every subset will be open because you can write it as U intersection N, where U is open in R. So proving that every subset of n is open in n with usual. Now, since every is open, so its complement will be closed. That explains your problem completely.
Yeah, the topology will be the discrete one.
Discrete one, yes, sir. On a finite subset of R, or if you take all, without limit point any set, then you will get discrete topology only. Yeah. All right, then I'll stop here for today.
Okay, thank you, Rajendra. Let us wait for, let us have a feedback session from our participants.
Yeah, sure.
Once again, yeah, I'm really happy with your session, and would like to thank you from my heart that your session was really great with a good collection of problems, and it's very interactive one. So it's really a nice experience for our members, I think. So dear participants, now it is your time. Please share your feedback, or if you have any query regarding your preparations, you can ask with Rajendra. He's really an expert in clearing this type of exams, so you can make use of her expertise. Yes.
Yeah, thank you all of you for your positive feedback.
Yes, Suraj is asking about the classes in Google Meet. Whenever we arrange some classes, we will share that information through our WhatsApp group as well as Telegram group.
Yeah. About the future classes, I mean, if there will be any class from my side, then sir will update you in advance. You can find some problem solutions online, which you might find on some YouTube or somewhere solved by me. So that can be helpful for you.
Yes, dear participants, please share your feedback.
Yeah.
Good evening, sir.
Yeah, good evening, Sita. Yeah, you are.
So my name is Shikha, and I've completed my integrated MSc in Mathematics and Computing from Birla Institute of Technology, and I'm from Jharkhand. So your session was today. Your session was really amazing, and I've seen your various sessions in different platforms also.
Okay.
And yes, it is always helpful for us, and it's easy to understand as well. So.
Yeah, I can hear you. I think we lost the
What should
connection.
our strategy for preparing for the months left for us?
I think now you really do not have so much time. There are, I think, 2.5 months mostly. Exactly, I think, not mostly. It's exactly 2.5 months. So for your part, I think you should be more on practice now, solve more and more problems. You can make a rule by choosing a subject, like you will do this subject for these many days. And also you need to plan, like make a plan, list all the subjects which you are going to cover for the upcoming exam, and divide the weekly schedule to subjects. Like, okay, this week you will do this subject, this week you will do this subject, and fix, like every day you will solve 40, 50, 70, 100 problems, as many as you can from the particular topics. Like you have decided today you will do real, or you will do for these upcoming 7 days you will do real. That is totally subjective, how you are comfortable with. But I think right now you will need to start preparing at war mode, like you are working like 24/7. Other than sleeping, you are just preparing for your exam.
Yes. Yeah. Thank you, sir.
Yeah.
Thank you, Shikha.
Thank you, Vinod, sir, for arranging such sessions, sir. And Rajendra, sir, we are hoping for more such sessions from your side.
Yeah, okay, I'll try to manage more. It was really a good session.
Yes, sir. Thank you, sir.
Yeah, sure.
Okay, others.
Good evening, sir. Am I audible?
Yes.
Yeah, you are audible. Good evening.
Sir, thank you. The class was really amazing and was truly helpful.
Okay.
Though I'm pursuing BSc, I will be appearing for JAM. But yeah, it was great for me too.
Yeah, okay.
Thank you, sir.
Yeah, you're welcome.
Okay, thank you, Sangsudha Mukherjee. Could you introduce yourself? You're from which place?
Sir, I'm from Burdwan. I'm from M.Sc Women's College, Burdwan, West Bengal.
Okay. Yeah, Sangsudha. All the best for your exams.
Thank you, sir.
Yeah. All right, then one thing I would point out that majorly you will see that people are hunting for, what is the answer to this question. I would suggest all of the people who are preparing is hunting for what is the concept behind this answer. So that will solve most of your problems, I think, and create many more problems for you. Yeah.
Yes, sir. Good evening, sir. I am 𝕨𝕬𝕥𝕙𝕤 from Kasganj.
Okay.
I am preparing for BS.
I think we can't hear you, Dharmendra.
I think.
Are you on mute or something?
Please unmute.
He's not on mute. I think he has to remove his earphone or something. Maybe something is there.
Yeah, Dharmendra, you are not audible.
Okay, sir. Okay.
Yeah.
Now, sir, it is okay, sir.
Yeah, yes.
Yeah. I am 𝕨𝕬𝕥𝕙𝕤 from Kasganj, and I am preparing for BA for IIT JAM and other exam also. This topic is tough for me. I want to ask from which book I should prepare for this topic, and what is the difference between point set topology and topology on R, and sometimes it comes with metric space also, so I confuse also in this topic also.
Yeah. I mean, yeah, okay. I think you are complete with your question, right? I hope so. Yeah. Okay. So, I mean, if you look for the book, then I think there are Indian authors and then there are foreign authors as well. So, if you are at very level 1, then you can prefer to SK MAPA. MAPA is fine. It is completely fine book for real analysis. It has a detailed solution to the problem, but at the same time, since it has detailed solution to the problem, it is not that good because there should be some open problems which are left for you. So in that case, you can refer to Bartley, real analysis by Bartley. You can find all these PDFs on internet these days. They are available. Even in the group, you might find them. So you can go for Bartley or MAPA. But if you want to go to the little bit next level, I will suggest you Apostle. And if you want to look for more, then go for Walter Rudin. So these are like level, first level, second level, third level, fourth level. So the first one would be MAPA. I would suggest you to start with SK MAPA. And difference between, the metric space is actually, it's a point set topology just when we talk about points and we try to, discuss topology about a point, when we can talk about points like this point, that point, and so on. In general, you have metric spaces and then you have topology, right? So from the metric space, you can get a topology. Every metric space gives you a topology by, you collect all the open set from that particular metric space, and then that actually satisfy that collection of all open set, satisfy the definition of being a topology. So every metric space, leads you to a topological space, but whereas converse is not true, that every topology is induced by some metric. No, those metrics, those topologies which are induced by some metric are referred as metrizable topologies, and rest are non-metrizable. So that is the next level you can go to. If you are looking for some basic book on topology of metric spaces, you can refer to Kumarasan, book by S. Kumarasan. It is really good, very compact book, and number of good examples are there. Very good examples. The only reason I like that book is that it has very compact and good amount of examples. If you want to go for detailed, then you can go for Munkers. Munker is like, exactly the Granth for topology. You can refer for Munkers. So yeah, to start with, go for this Kumarasan. That will do for NET, GATE, JRF all.
Thanks, sir. And I want to ask your experience of research and what topic you selected?
Yeah, so I am in my third year of the PhD, and I selected algebra. It's somewhat applied algebra. We try to figure out some problem in the communication systems. We make some codes using finite fields, or you can say that finite dimensional vector space over finite fields. We use that and try to each vector is some code word, and we can we can use them in the communication system as well. So that was amazing for me to find out in the beginning that abstract algebra has such practical examples, abstract and linear together. So we are using that to develop some code in which we can send a message from one place to another place, and then that message is actually coded using the vectors in a finite vector space. So that is what my research area is. We are trying to develop some codes, and so it is actually algebra. You can take this subject after the algebra. So I'm doing in that. I think that answered your question.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Thank you, Dharmendra. Is others?
Am I audible?
Hello, sir.
Yeah, yes, Haritha, you can speak.
Thank you, sir, for this amazing session. I'm really helpful by your session. And I'm from Burdwan, and I'm pursuing my BSc degree from Burdwan Raj College.
BSc?
Yes, sir. I'm
Yeah.
in third year of my BSc, sir. And
You are
I
in
am
third year.
preparing for JAM.
Great. Keep it up.
Thank you, sir. Thank you,
Thank
Vinod,
you.
sir.
Yeah, thank you, Rhythm. All the very best for your exams.
Thank you, sir.
Yeah. Yes, Haritha.
I hope I'm visible. Hi, sir. My name is Harita. I'm from NIT Calicut. I'm a first year MSc student. We just started our classes and I'm starting my CSIR preparations. You could say I'm at the very beginning level. The classes was nice. I kind of really like topology, though we haven't started topology yet. I have attended topology classes from some of my summer classes like MTTS and Vegan Vidushi like that, which was a bit high, though I like topology in somehow. So I was interested when Vinod sir told today we have class in topology, and it was worth it. Class was very nice. I really liked the classes, and it's kind of a good kickstart. Thank you so much for this opportunity. And I think I was about to ask which book should I refer for the starting level. We are actually referring to Rudin, and I feel it's kind of concise. They're skipping most of the steps in the middle. So I'm lacking how to connect the steps. I don't know what to say. So I think I should start with MAPA now. And thank you so much for the opportunity. And thank you so much, Vinod sir, as usual. He's always our savior. Thank you, sir. All the best for your career also.
Yeah, thank you. So yeah, you can actually if you are at starting with Rudin, then the purpose of starting with Rudin is suffer. Okay, so you need to suffer that period. It's that is the part of learning. You need to bang your head in front of wall and try to understand one line of that again and again. So that is part. But again, if you are finding it very difficult and not able to understand something, then you can go back and refer to some basic books and come back here. Okay. So I think doing Rudin will be really good for you if you are able to manage that.
Yeah, Rodin is very particular for the preciseness and compactness in arguments. It's really a little bit difficult for the first time learners, but if you can follow that, it will be a very nice experience and will be a very great, it will be having a good advantage in your future studies as well.
Yeah, exactly. But if you are focusing on particular exam like NET JRF, then don't stuck behind a book.
Yeah, it's okay. It's Rodin is actually for studying the subject and studying the concepts, but for practical this type of competitive examinations, of course you need to go through other books as well.
Yeah. So like once you qualify the exam, you have qualified the JRF exam, then you can go for these book for your interview preparation and your knowledge level testing. Because then you will be you will be paid for studying those books for every month. So the step one is to get stipend from someone to read those books, and then read those books and get payment for that.
And let me add one more thing. This book, Rowding's book, Principles of Mathematical Analysis, is actually the most simplest one written by Rowling.
Yeah.
The other books by Rowling are really tougher than that. And
Yeah.
the interesting thing is that this book is being written at the age of 25.
Yeah. This book is also nicknamed as Baby Rudin.
Yeah, Baby
There
Rudin.
is a real and complex
Considered as Baby
analysis by
Rudin.
Rudin. That's Papa Rudin. And then there is a functional analysis by Rudin. That's Grandpa Rudin. So you have Rudin's book for all of your age. So
It's
always
very
there.
nice. Yeah, thank you, Harita. Yes, others?
Thank you, sir.
Hello, am I audible?
Yeah,
you are
yes.
Lakshmi.
Hi, good evening. My name is Lakshmi. I'm currently in my final year of BSc Honours from Hansraj College, Delhi University. We also actually started with our 5th semester. We have a paper on metric spaces. So, ma'am keeps mentioning topology in the class that you will go further, you will study topology. So, it was really nice getting that opportunity now, familiarizing ourselves with the topic. Thank you so much for taking out the time. Looking forward to more sessions.
Yeah. Okay. All right. Thank you.
Thank you, Lakshmi. Any others?
Yeah. I think all
Yeah,
is done.
Yeah, if any of you.
Am I audible?
Yeah, yes.
I hope I am visible too.
Yes.
I am Anamika. I'm a graduate and now I'm preparing for IIT JAM exam. And you told that this questions majorly from CSIR net based questions, but your explanation make those questions and answers simple, sir. Very a great session, sir, and love the questions very much. And we are eagerly waiting for great such selected questions. Thank you very, very much, sir. And thank you, Vinod, sir, also.
Yeah.
Okay,
Thank you so much, and you're welcome.
Okay. Yeah.
Sir, am I audible?
Yeah, yes, Aditi.
Yeah. Hello, sir. I'm in ICT Mumbai, pursuing my MSc first year.
Okay.
And thankfully I've been across this math aspirant group and attended to today's session. So actually, I like the viewpoint. Whenever we saw the questions, the way we used to think actually changed. Like a bit, but it changed. So I will be appearing in JAM exam the next year. So I think it's going to be a really helpful session for me. Thank you.
Yeah. Okay. You're welcome.
Thank you, Aditi, and all the best for your exams.
Thank you.
Yeah.
Okay. Yeah. Yes, Aparna. Aparna, your voice is.
Your voice is very low, Aparna. I think it's not even audible. Can you do something? Can you mute yourself and unmute or something? No, it's not. Still not audible.
Some issue with your voice, I think. You are not audible.
If you have earphone or something, Aparna, try removing it.
Maybe due to some network issue, or I don't know exactly.
Yeah, I think. Yeah.
Okay, dear participants, we are almost out of the time. If any of you would like to share any feedback, you can do that. Otherwise,
So I want to add something. So please don't forget to share your notes.
Today's class printout I can share. Otherwise, you can find some more, solved problems and some more content which actually I'm publishing on a website which is called 𝕤𝕒𝕒𝕙 Mathematics. So I'm trying to solve, some problems from the mathematical background from here and there and publishing their solutions regularly, and they all are, of course, of no cost.
Okay, we can share the address of your website with the recording of this program.
Yeah, sure.
Yeah, Lakshmi. Yes.
Thank you, sir. Thank you, sir, for this wonderful class. I am Lakshmi. I am from TNC College, Tirur, Kerala. Today's class was really nice and interesting. You explained each and every question clearly. And thank you, sir, for spending your valuable time with us. And thank you, Vinod, sir, for conducting this class. Thank you.
Yeah, you're welcome.
Thank you, Lakshmi. Any others?
Hello,
Otherwise, we'll, yeah.
My name is Devananda. I'm in my third year of BSc. I'm currently going to do my JAM exams. So I actually tried to do the questions with you, but I always got at least one option wrong, and the final question was the only one I got completely right. So MSQ questions are always very tough because we have to always check each and every option throughout. So you explained it really well. I could understand it to an extended level. Thank you so much, sir.
Yeah.
Thank you. Thank you, Devananda. Remember that the only way to learn things is the practice. Practice, practice, and practice. That will make your answers the right ones. Okay, don't worry about that. Keep on practicing with more and more problems.
Yeah, true.
Yes. Yeah. I think I think your network is, your voice is not coming.
Some network issues again, I think.
Yeah. Okay, maybe it is around almost the data is being exhausted.
Yeah, I think 1 GB is gone.
Okay, so I think we can wind up here. So once again, Rajendra, I'm very much thankful to you for this nice session, nice and vibrant session. And you have explained the things in a very nice manner, so that how to, so certainly our members have got some idea to explore the MCQ type questions. So I'm sure that in the future, we can arrange some sessions that will address questions from multiple select type as well, numerical answer type for JAM. So yeah, according to your availability of time, we can think about arranging some sessions in that direction.
Yeah, specifically, I was thinking about 2021's JAM exam. That is like amazing pure mathematics is there.
Yeah,
We'll do in some near future. I would suggest all of you to try to solve that question paper. That is very good.
Examination conducted by IISc.
Yes, exactly. That was a pure mathematics was amazing. You know, in that paper, it's beating NET, JRF, and GATE even.
Okay. So thank you. Thank you, Rajendra, once again, and thank you, everyone. Okay, let us wind up here. Good night.
Yeah, all right. Thank you, sir. Good night, everyone, and such a good audience. Bye, everyone.
Thank you.
And yeah, you're welcome, all of you.